Welcome back. In this lecture, I'll tell you about a few more formulas on integration, and then we'll discuss a subcategory of integration, that's what we call as definite integral. We'll do that, but before that I may also tell you about a few problems which I have given for you as an assignment. These are the problems on differentiation and these are the problems on integration. I hope you will try them, and if you are unable to solve these problems, you can write in the comment box. I will help you with these problems. The solutions to these problems are also given in my book Systematic Physics by Kalyani Publishers. You can also refer to that. Well, let's start with a few formulas on integration. We have already done that integration of x raised to power n dx, provided n is not equal to -1. Accept -1 and can have any value, real or fraction or integers, natural numbers, decimals, anything. They can have positive, negative, anything. But accept n is not, accept -1. So the integration for that is x raised to power n plus 1 over n plus 1 and a constant of integration c, which we already know why to put. Along with that, if there is one number x, that means if it is x raised to power -1, the integration would be log x plus c. Even if I forget to write down plus c, it is understood that it is very much there. In addition to that, now I will give you a few formulas based on the trigonometric ratios. The integration of sin x is minus cos x. The integration of cos x is sin x. Integration of, obviously dx should be there. Integration of secant square x is tangent x. Integration of cosecant square x is minus cotangent x. Integration of secant x tangent x is secant x. Integration of secant x cosecant x cotangent x is minus cosecant x. These are the 6 formulas for trigonometric ratios. You can see what we are doing. The differentiation of sin x is cos x. Therefore, the integration of cos x is sin x. Integration of cos x was minus sin x. So therefore, differentiation of cos x was minus sin x. Therefore, integration of sin x is minus cos x. And in all other cases, you can verify these results. Let me tell you that integration of e raised to power x still remains e raised to power x. These are a few formulas which you may need for solving these things. For example, in this case, what you should try. You haven't done any formula given to you earlier. So you need to change this to something similar to the formulas you know. How would you do that? Let's say this is cos x over 1 minus cos square x. What you can see, 1 minus cos square x is basically sin square x. So what do I get? Cos x over sin square x. I can write down sin square x as sin x into sin x. 1 over sin x becomes cosecant x. And cos x over sin x will become cotangent x. So what do you get? You reach this formula as cosecant x, cotangent x, and the integration is known to you. So this is how you can change the appearance of these expressions in such a way that you change them to more familiar shapes, and once you change them to those familiar shapes, you would be able to integrate those functions. Now, let's see what are definite integrals. In definite integrals, 2 limits of integrations would also be given to you. Let me tell you how. The question on definite integral would be something like this. Integrate cos x dx from minus pi by 4 to plus pi by 4. This is called lower limit, this is called upper limit. But to start with, you need not to worry about the limits at all. You need to take it as a question on integration and solve it the known formulas to you. For example, the integration of cos x we know is sin x. In case of definite integrals, we don't put the constant of integration, because that will not obviously. Now we are specifying, let's say this is cos x, this is the area. This is 0, this is somewhere cos pi by 4. So you are putting a limit on the area. So you don't need to put a constant of integration. Sorry, this was minus pi by 4, so it's somewhere over like this. We know that this is pi by 2, so this is pi by 2. So you wish to find out area somewhere in this region from minus pi by 4 to pi by 4. So the area is specified, so unknown constants need not to find any place in these expressions. So what is the integration of cos x? It is sin x. What you will write down? You will write down its limits minus pi by 4 to pi by 4. Then wherever you have got x, first replace that x by the upper limit. So it becomes sine, instead of x, I write down sine pi by 4, the upper limit, minus. Then write down the same expression but with x replaced by the lower limit, sine minus pi by 4. Solve it out. Sine pi by 4, that is sine 45, is 1 by root 2 minus sine minus pi by 4 is minus 1 by root 2. That becomes 2 by root 2. That becomes under root 2. Since it's an area, we should write down square units. So this is how a definite integral question is proceeded. I do one more example. Integrate x square plus 3 from 1 to 2. What we will do? First, we will forget about the limits. Just integrate it by the law formulas. X cubed by 3 plus 3x is the integration. Limits are 1 to 2. So, first replace x by the upper limit. So, it becomes 2 cubed by 3 plus 3 into 2. 3x changes to 3 into 2 minus. Now, in the whole expression, replace x with the lower limit. So 1 cube divided by 3 plus 3 into 1. This becomes 8 by 3 plus 6 minus 1 by 3 minus 3. So it becomes 8 minus 1, 7 by 3, 6 minus 3 is plus 3. This is 16 by 3 square units. So that's the answer. That's how you proceed with the questions on definite integral. I give you one more problem. I'll add that to these list of problems which are given you already. Problem based on integration. Let's say this is 7x cubed plus 3 dx minus 1 to plus 1 and cos x dx from minus pi by 2 to plus pi by 2. Solve these values. I hope you will try these questions and respond to me in the comment box. Thank you.